Okay, so this video here is on the Y junction that Combatants wants you to do for unit standard 25705. It's made out of 3mm steel sheet, and it's a 60-degree opening at the top. Down the bottom here, they're showing the two side branches coming into a flat cylinder across the top. You cannot draw it like that for a parallel junction. Doesn't work, so I'm going to show you what needs to be done. You're going to have to use a common central sphere. So I'm going to start drawing it right from scratch so you can see the whole thing. Go back and to model, and they're asking for 100mm OD, and it's 3mm material thickness. So whenever we draw something, we have to draw it to the mean diameter for a pattern. So it's going to be 100mm minus the 3mm thickness of material. So I'm going to start off with my baseline. So 100 minus 3 is 79mm. I'm just going to come up roughly 150 and put a center line in. Repeat line, do it from the midpoint, come up 150, and on the top of that 150 I'm going to draw a circle. So this is going to be the common central sphere, being 97mm diameter, has a radius of 48.5, and I'm going to bring my baseline up on the other side. Just come up to the edge of the cylinder, that'll do. I have to go away at 30 degrees on each side, so I'm just going to type in a dimension of 400. Same out the other side. You'll be using your 3060 set square for this on your piece of paper. 400. And what I need to do is to offset those two lines. So O for offset, 48.5. And I'm just going to step these two lines off either side. Now what they are specifying is this length up the outside here of 300mm. So I am going to put that 300mm in. So what I want to do is from there is to put a line from, pick the point that I want to go from. So I want to go up there 300mm. And then I want to come across, so there's my 300 leg length. I'm going to put these three lines on my center line, and I'm going to trim out what is not supposed to be there, and I want to put that around the corner as well, so I'm going to do a mirror function on that. And I'm just going to pick that point to that point there and hit no, and that gives me my other side. So do a trim. So you're going to set this up just like I have done. Now the common central sphere, our two lines intersect at this point here, this blue point, or this pink point here, does exactly the same on the other side at that point. And there's our top intersection point. Now they all go through to the center of the sphere that we've drawn. Very good reason for that, which I'm going to explain. So I'm going to get rid of what I don't want. Get rid of that. And I'm going to come down the bottom here from this point here and this point. I get rid of that, I get rid of that. Same on the other side. Pick those two lines, enter. Done that, and we'll just put the circle in the background because it's served its purpose already. So we're going to fit this on a sheet. What I'm going to do is I'm going to draw it full size, and then I will fit it onto a A3 sheet of paper so that when you come to draw it and develop it, you can see what size. You're going to have to scale it to get it to fit on the sheet. I'm drawing it full size for you. So there's a reason that I have drawn it with a common central sphere with this top on it instead of a flat base across it. And the reason is that if I draw this line across here, which would be the flat line that is shown in the competence drawing, that in actual fact is a circle, but when we project this, actually I'm going to extend that line out slightly. I'm going to take it out to here, and I'm going to project this outside edge here of this one here down to that point there, and I'm going to trim that off there. So what we have when we look down on it is, C for circle, from this position we would have our circle on the top of the cylinder if we were using the cylinder. But when this branch coming in on either side, when you cut a round cylinder with a inclined end, you get an elliptical joint. So the ellipse would look like, okay, so what I need to do is just put a little line in here, and I'm going to extend this line across here, and what I'm going to do is I'm going to do another line. I'm going to pick a midpoint. We've got a midpoint, there I am. I come down, and that's my midpoint. I'm going to draw it to there. I'm going to trim it back because it wanted to click onto something else. So we get rid of that. We'll get rid of, sorry, not thinking. So if I take if I type in ellipse, and I pick my two ends of the ellipse, and it stretches out to this point here, you can see that the ellipse for even half of it comes to this particular line here, whereas half of my circle, which is that point there, comes to the center line. So if I trim out some of this, I might be able to show you slightly better than what I'm describing. So that's where my circle goes to, ellipse goes to, and that's where my, no, I'm not going to do that. I'm going to put that line in, that line, and then trim that out. In fact, I need to trim out even more. I trim, okay, so that doesn't exist there. That was slightly different. So, and I'm going to take that off the top there, trim that. Get rid of that. So half of a circle is this line here, whereas half of the ellipse is this longer line that extends across to this point here, which is that one there. So you cannot put a circle or bring two cylinders in with an inclined end and expect the two joint lines to meet. Just removed the line I shouldn't have. So what I'm going to show you now is that this cylinder coming in, and this cylinder coming in at 30 degrees here, and the one coming up from the bottom vertically, we're creating a joint line which is a split perpendicular. Where is it? There it is there. So this joint line here is actually a split between the two. So it's an elliptical joint, but it's half of the cylinder coming in from the top, and it's half of the cylinder coming in from the bottom. So dim angle, I can show you exactly half. It's 15 degrees, and coming in from the vertical approach, it's 15 degrees as well. So this joint line that we're doing here, we have to determine that joint line with the one going up vertically up there. We have to create that scenario to actually get our cylinder to work. Otherwise, we're not going to be able to join the two branches, the two Y branches coming into the base one. So that's what that was all about, of using a common central sphere. I do have another video on YouTube about that, if you're interested in looking at that. So that's all the information that we needed to start with. Running off the screen, bring it back. So, starting to develop the pattern. Well, what we need is a semicircle on the base. Now, I've explained this before. If you haven't seen my videos, I have to use full circles, whereas you will be just using your compass to draw a semicircle. I will extend my center line down to the base, and then I draw my circles out the other way. Once again, you will be using your compass at this point to create these points that I am having to do a different way. It's exactly the same process, it's just that in Autocad I have to do it this way. So I'm creating my points here on the bottom. I'm going to trim all this out and you'll see my points. So trim each circle, missed it, trim, come back up here. So I'm going to hit that line, and which one am I hitting? I'm hitting that one there. Then I hit this line here and get rid of that. Do exactly the same on the other side. Oh, sorry, I've missed a point there. Actually, I'm going to just go with what I've got on the screen already. I'm not going to go any further. I'm going to use those 2 points. So I get rid of that and I get rid of that. So this is the points for my semicircle. I want a line. So I'm going to go from here vertically up to the joint line. I'm clicking on different points, so I'm just going to go up. I try to do these videos as quickly as possible and not change around too many things. So if I wanted to develop just this component on the base here, I've already got enough information on the screen to start developing it. Up on the top right hand side, we'll do this one here. We'll draw in our circle here. Once again, you will only be creating half of it. I will extend that through the center line through to the end because I need it. Trim it off at that point there. And once again, I'm going to create my points up here, and I'm going to create them on both sides this time because I need them on both sides. To that point there, little wee circle around it so I can trim it out. 5mm again. Come back to trimming it out. So I'm going to hit that one and that one. So I get rid of that and I get rid of that. And then this circle and this circle, get rid of that, get rid of that. And take these little circles out to save confusion. So I project those points back down. So from that point, I come all the way down at 30 degrees. And in this particular drawing, if I just, where am I? 30 degrees. I haven't got 30 on the screen, so I just need to come down and polar tracking. 30 degrees. Now if you look, you can see the line, the green line projecting down, and it hits the one exactly, the one coming up from in underneath. If you've drawn this correctly, you will get that. So the next one coming down, it's going to hit the next point coming up from underneath, and then I need the two above that to develop the top pattern, top half of the pattern. It's going to come down at 30 degrees. I'm going to go slightly past and trim the line, and this one here to that point there. So just on that joint line, trim those out. So these projection lines, I'm going to call them the projection lines, and we'll do the same for the circle on the top and the ones coming up from underneath. Have I got a, yeah, I'll put it on the same projection as the, we'll take that out now so we can see that. So I've got enough information there on the screen to actually start developing the pattern. I'm just going to start numbering it so that the numbers are really clear. So I've labelled everything. I've put the dimensions on, so 300 up this outside leg, 60 degrees in the centre, 97 millimetres across the end, which is double of the down the bottom here, 48.5 for the radius. So we're going to start to lay out the pattern. I'm going to start with the base one. So what I'm going to do is I'm just going to offset this outside line here, 10 millimetres across. Select object, step it across. My rollout length for my cylinder 97 millimeters. Pi for combatines is 3.14, so times 97 by 3.14, and I get a length of 304.58. So offset 304.58, enter, step that across. I need to draw my line in across the base here. And what I need to do, sorry, I'm going to grab that line and go up slightly. What I need to do is project these points where these, where this pink point is here, the next one, the blue one, or the pink one there. These are my heights that I'm looking for. This one here as well. So these go across the sheet. So we project them 90 degrees to the, or perpendicular to the lines that we've got here. So they're going to go straight across perpendicular. Get back on the sheet mark. Next one, straight across, just to that outside line. Next one up, straight across. And the highest point, this point here, straight across. Zoom out slightly. So I'm going to trim the outside edge. I'm going to just type in TR instead of looking for it all the time. Get rid of that. Now what we need to do is break this baseline, the 304.58. We need to divide that by 12 equal parts, which gives us 25.382. So I'm going to offset, how do I want to say that to you? I'm going to offset across 25.382, push enter. I'm just going to keep doing that. And I'll explain the different ways of doing this. It's all very well for me doing it in Autocad, but you're doing it on an A3 sheet of paper. So there's my 12 equal divisions. What you would do with your compass, you would go from this point here and scribe an arc. This here has a, well, I can show you, it has a radius here. See the radius, it says 25.382. You would just keep drawing them, but you wouldn't have this arc going all, you wouldn't have a full circle, you just have a small arc across the line roughly where my crosshairs are, and you would keep doing that across there. Next one, so from that point do the next one, from that point do the next one. You can take that length there from D to C, or C to B, or from B to A. That dimension there, if you look at it on here, so I'm going to do a dim align, and I'm going to take it from that point there to that point there. We have 25.11. We'll go to 3 decimal places, we'll go up to precision, 3 decimal places. So we've got 25.105, but that's a straight line length. That's a chord length across a circle for a 30-degree angle. Whereas if you look at the pink line going from D, it's slightly further out round to C, and that's going to be the difference of the, I stepped across here at 25.382. Whereas this is only saying 25.105. If you did it at 25.15, it would be slightly too short. Gosh, that's a whole discussion I need to have with you as well. I'm going to come back to that. No, I'm not. I'm going to do it right now. So, if we want to lay a line in, I'm just going to come down a bit, and I'm going to lay my line in. I'm going to type in the 304.58 again, and I want to break that into 12 equal parts. Now the best way I can do that for you, put my vertical in, a short vertical, just to explain how this works. What I would do if it was me personally, I would draw a midpoint on that line, which is there. Now you can just take that line and divide it in half and draw a vertical line in. And then what I would do is I would break this next portion between this point here and this point here. I'd break that in half. So how do I want to do that, Mark? I'm going to split that line, so I'm going to do a break. Pick my line, type in F, do the same again. So now I've got this line in 2 halves, and then I'm going to put another vertical line in, and I'm going to pick the vertical line from the midpoint again. There's my midpoint, and I would do exactly the same on the other side as well, from the midpoint. So I've broken my line up and already broken it into quarters. So what I want to say is, if I use that dimension of 25.105, let's do it. Circle from that point there, 25.105, and do it again, and do it again. You can see how I am short, and in this case, well, let's measure it so you know, distance from that point to that point there, it's 0.83 of a millimetre. Now if I was laying out a pattern, what I would do is I would then start from this point here and do my 25.105. Do it again. So what I'm trying to do, if I take that 0.83 that was at that point there, and I times that by 4, that means by the time I get across to the end, from this point here across to this point here, I would be out by 3.2, I'd be out by 3.32 millimetres. But because I've gone and broke my line into quarters for a start, I can divide that 3.32 millimetres by 4, and I'm only out by 0.83 of a millimetre. So you can't set your compass or your dividers to any more accuracy than about 1 millimetre. So you can break your discrepancy up across that whole baseline by breaking it into quarters instead of stepping these circles all the way across and finding that you're going to be short. So that's how I would do that. I hope that makes sense. It certainly makes sense to me because I've done it 1,000 times, but it's not always making sense to a person that's just starting out. So, anyway, you might have to watch that 2 or 3 times to make sense of that. So I'm just now going to number these lines across the bottom here with the A, B, C and D across here. Right, so I have gone and written the letters across the bottom. The joint line is on the D, so I go from D down to A, back up to D, down to A and back up to D. So what I need to do is extend my lines through to the top line, which is the highest point. So that is D. I'm just going to put them all in here. I'm trying to do 2 things at once. I'm watching my video so it doesn't stop. So I've got all my high points, and now what I need to do is to draw my joint line in of what the actual line would look like, and I'm going to use the spline function on the computer. What you would do is just join all the dots together. So what I'm looking for is where line D is going up, I'm looking for line D going across, and that gives me this point here for D. If I was looking at line C, this would be line C going across here, and I look for the line C's. All the C's will have that elevational height, so I would have a point at that intersection point there. I'd have one there, I'd have one there, and there's another C further out that I would have as well. So what I'm trying to do is a spline. You will sketch through here with a pencil, whereas I'm drawing it in like this. So up to D, and I need to make sure that I don't move on that, and then I start it again, and I go down from here down to the next one, down to the next point, down to there, up to there, up to there, and to that point there. Type in T for me, and there's my joint line. So What I will do is I will trim out everything above that joint line for clarity. Have I gone far enough? There's still a line there. I will put these lines here in as joint lines. Projection lines, sorry. And in actual fact, I'm going to put all these ones in as projection lines coming up from the bottom as well. So that's the rolled out cylinder. The highest point is from this line here to the bottom. I project my baseline horizontally across the sheet, 90 degrees to, maybe I'll do that, dim ANG. This line here is 90 degrees. You can see it's 90. So this line is going all the way across here. I've stepped off 10 millimeters only to create a slight gap here. This is my joint line. When I roll the cylinder up, in actual fact, I'm looking at the inside face of it there, so M text. And I'm just going to write inside. So when I come to roll it, I know what I'm looking at. You would simply write on it with a felt tip pen, text height, we'll do 8. So that's the inside. You'd write on it a felt tip pen, so when you went to the rollers, you would know that that's the inside when you were going to roll it. As I said, it has no allowance for a lap because it doesn't need one. It's in 3mm steel. You might chamfer the ends, but depends what you're trying to do really at the end of the day as to how you're going to join it. So that's the base cylinder. Now I want to project this away and create one of the branches coming into it. So what I'm going to do is I'm going to completely remove this branch on this side. And what I need to do is I need to project up the sheet. So what I'm going to do for a start is I'm going to offset it 10 millimeters yet again. And I'm going to pick that line and step off 10 mil. And once again, the rollout length, where's my line function? Going from here at 30 degrees, which is perpendicular to that line, I need to type in 304.58 millimeters, which is what it was. And then I would come back down here. Well, I'm just going to come down 400 because I don't know what the height is. And then what I need to do is take all of these points and project them up the sheet. You will be using your set square. So, what did I say? 304, so 314.58 for that one. I'm just going to run these slightly longer on these ones because I don't know what length they're going to be. Well, I know what length they are, but I'm not going to waste my time doing it, otherwise it'll just slow the video down even more. As it is, it's going to be a long video, which I didn't want it to be, but there's nothing I can do about that. So 400, and we're still going far enough. I might have to go a bit further now. I might have to go 500. 500, and once again 500. So all these lines go out to this outside edge. I am going to trim them off. Where's my trim? Trim them all here. Get rid of them all because that's the length. The top length is that one there. So I need to step across here and draw my circles in. So I'm going to do C, and it was 25.382. Just laying all these in. And now I need to project all those lines down. So I'm coming from this position here. I come back down here. Sorry, I'm drawing a circle on a line. I want from this intersection down here, I want to come down here at 60 degrees. Once again, you will do this with a T-square and a 30-60 set square to get your correct angles. And what I'll do is I'll trim all those out straight across there by double clicking on trim. And I'm just going to pause the video for a moment. I'm going to get rid of all my circles now that I've got all that in. And I'm going to number everything across the top here. So this is our joint line, so our two outside edges, this one here and this one here, will be our longest lines. I just need to extend this one on this side through. Numbered everything. What I'm going to do is I'm going to pick all these lines across here once again and turn them into projection lines. So onto projection, and the ones coming up at 30 degrees will also be projection lines. So in order for the cylinder to roll out correctly, the joint line is on number 3, so we have 3 at the start, we have 3 in the middle, and we have 3 at the end. This portion, this line here will roll across from 3 towards the other 3. So we have on this end we have 3, 2, 1, 0, 1, 2, 3. This line is heading in the opposite direction. It's heading out this way. It's rolling back across. So on this side we have 3, 4, 5, 6, 5, 4, 3. So that's how we have those lines going across there in different ways. And I also need to number my lines very carefully coming up, because 3 is actually the high point. The next one down is 4, 5 and 6. So they're not all numbering from the bottom as in 0, 1, 2, 2, 3, 4, 5 and 6. They actually go from 0 to 1 to 2 to 3, then back down to 4, then back down to 5, then back down to 6. So you need to very carefully make sure that you pick up the correct lines, otherwise you are going to have a wrong looking pattern. So what I need to do is get line number 2 intersecting at line number 2, and obviously line number 1 and line number 1 would be intersecting. So doing a spline, you will sketch through here once again with a pencil. Or a French curve. You can use a French curve. I'm not great on French curves, but it's only a personal thing. So up to 1, up to 2, and then back up to 3. I missed it. You don't want to do that, Mark. You've got to start again. So 3, 2, 1, 0. Picking up these intersection points. I need to lock my hand down on the table. So, and then from there, I need to think a bit here just for a moment. So I'm going 3, 4, 5. Okay, so I'm going from 3 to 4 to 5 to 6. Scroll out a little bit. Back up to 4, up to 5 and to 6. Lock my hand on the table. So there's my pattern across the top. I will trim out what I don't want to see. So we'll get rid of that line, that line, that line, that line and that line. And then on this side, I am going to get rid of 4, 5, 6. I'll get rid of those as well, just to be a bit pedantic. And zoom out. So there's my pattern from this point here across to this point here for this branch. I have laid that out with that being the inside as well, so I will copy that and then I will paste it. So you're going to write on the inside of it. No, you're not going to write it there, you're going to shift it. It's just going to muck me around. Why are you doing that? Move. Just trying to click on 4. There we go. So that's the inside. You would do another one, inside out. You'd mark 2 of them out the same. You'll roll one on the inside, and your other pattern would be the outside of that one, so that what they do is all the joint lines come to this position on the side here. The other joint line going up there at 60 degrees or 30 degrees to give you a 60 degree V. That's if you want all the joint lines on the same side. It's entirely up to the individual what they're trying to make, but that's how you lay out a pattern for a 60 degree Y junction. Now you've got to fit all that onto an A3 sheet of paper. So a couple of points. We took the diameter, which was overall of 100 millimeters, and we had to minus off the material thickness. That made it 97 millimeters. So this baseline here is 97 millimeters long. If I show you, and here delta X is 97 millimeters long. That's what you have to work to the mean line when you're doing a pattern, and that mean line is dictated by the material thickness. So I'm going to leave the video there.